Good afternoon, class. We are looking at pre-calculus practice test number 4, module 4, covering chapters 8 and 9. And here's chapter 9, systems of linear and nonlinear equations. We're going to look at a couple of parts. The first part, reminding everybody about the pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during the exam, any exam. And I want to emphasize that. In other words, when you take the exam, it is as though you're taking it in class. That is extremely important for everybody to pay attention to. And then we're going to move on. Systems of linear and nonlinear equation. Number one, if the system of linear equation results in two parallel lines, the system is an inconsistent system. The system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts, as you can see from the graph here. The two lines have equal slopes, but different y-intercepts. If you were to solve it by some method, for example, addition method, or substitution for that matter, you get a contradiction such as 0 equals 7, 2 equals 5, and so on. If the system of linear equations results in two intersecting lines, the system is, it's a consistent system with independent equations. The system has a single solution at the point of intersection. The graphs are different. They have different slopes. So they look like that. Basically, if you solve for y, you find different slopes. That's all. Finally, and if the system of linear equations results in a single line, the system is, it's a consistent system with dependent equations. That's the key. The system has an infinite number of solutions. The graphs are identical. They have the same slope and same y-intercept. So looking like that. In other words, if you solve for y, they become identical. M1 equals to M2 also B1 equals to B2. An identity such as 0 equals 0 indicates the system has an infinite number of solutions. The equations are dependent. So basically what happens, we get an identity if we go through the process of solving it. So we want to solve this system. Minus x plus 2y equals -1, 5x minus 10y equals 6. And there are different ways of handling it. One is to figure out you want to get rid of one of the variables. For example, if I want to get rid of x, I can multiply this one by 5. It's called the elimination method. So if I multiply this by 5, what happens? I get minus 5x plus 10y equals -5. I'm going to repeat the second equation unchanged. If I add them up, these two cancel each other. So the left side becomes 0, but the right side is not 0, is equal to 1. That's a contradiction. That's a false statement. So false. Therefore, this is an inconsistent system. The solution to the system is an empty set. You use a couple of braces, nothing in it, or phi. This is phi representing an empty set in set theory. What about this one? If you want to solve for x, you can multiply this one by 5, this one by 2. If you want to solve for, if you want to get rid of the x. If you want to get rid of the y, you can multiply this one by 3, with this one by 7. The point is, depends on which variable you want to get rid of. Let's say we are getting rid of the x, so let's multiply this one by 3 and this one by 7. So what do we get? The first equation becomes 6x minus 21y equals 9. The second one becomes minus 35x plus 21y equals 49. And we add them up. These two cancel each other. These two add up to negative 29x. These two add up to 58. You divide by negative 29, x becomes negative 2. You put it into one of the original equations, for example, the first one. You get negative 4. You move it, you make it positive 4. So negative 7y equals 7 divided by negative 7. And you get negative 1. So that's the pair. And notice we used equation 1. We have to check with equation 2, the one we haven't used yet. So minus 5 times x, which is negative 2, plus 3 times y, which is negative 1. Is this equal to 7? Yes, 10 minus 3 is 7. So you just check. Takes a split second. And that's the beauty of math. You can check your work, everybody. So make sure when you can check the work. Now let's look at matrices, a rectangular array or table of numbers. A matrix with m rows and n columns has dimension m by n. So this one, 1, 2, 3, and it continues. M rows, 1, 2, 3, and those are the number of columns. So for example, this entry is A11 because it belongs to the first row and the first column. But this one is A21. You write AIJ. So the way you write it, everybody. And entry is AIJ, where I is the rows, okay? J is the columns. So the first number represents the number for rows, okay? Which row? That's the case. A square matrix has the same number of rows as columns. The dimension would be n by n. Over here, first we mentioned the rows, okay, n by n. Over here, both of them happen to be the same. We can add matrices with same dimensions only. The dimensions must be identical. So if I'm adding, I add the corresponding locations. Those two, I add them up. And that becomes 1. These two, I add them up. And I get 0. These two, I add them up. I get 16. These two, I add them up. And I get 6. So the corresponding location, okay, they can be added. Now, the product is a different story. The product AB of an n by n matrix A and n by k matrix B is m by k. What do we mean by that? I want to make sure we understand that. Number one, The number of rows and columns. This one, when I write the number of rows and columns, 2 by 3. Now, if you want to do the product, this one must be 3 by something. Happen to be 2. But the point is these two numbers must be identical or we can't multiply. Okay, so m by n, n by k, and the first number, the result comes from this one, the last one comes from this one. So 2 by 2, the result. So I always start by writing the dimensions. The result must be 2 by 2. So again, one more time, we have 1 and 2 rows, 1, 2, 3 columns, 2 by 3. We have 1, 2, 3 rows, 2 columns, 3 by 2. Because these two are identical, we can make this happen. And the result is 2 by 2. So I wrote the result. Now, how do we multiply them? We multiply this one by this one. And we add them up. So I'm going to write it up here so everybody can see what I'm talking about here. So let me erase this part so I can use this. So I am going to multiply -3 by -6, 4 by 2, 2 by 3. So I get 18 plus 8 plus 6, 32. Now, so one more time. I multiply this one by this one and I get the first entry. Then I multiply by this one and I get the second entry. So let me show you that one. That would be, let me write it here, -3 times 4 plus 4 times 3 plus 2 times -2. These two cancel each other. We get -4, which means over here, and I'm going to erase it in a moment, but over here, I'm supposed to have 32 here and -4. Okay. So let me do one more just for the sake of argument. If I multiply this one by this one, I get this entry. Okay. So I get 5 times -6 plus 0 has no bearing, but anyways, let's write it down. 0 times 2 plus 4 times 3. I get -30 plus 12 is -18. So this entry is -18. And finally, you multiply this one by this one. 5 times 4, 0 times 3, 4 times -2, and that gives you 12. So I'm going to erase my work. That's the final answer. And more importantly, it's a 2 by 2. Matrix methods to solve systems of linear equations. REF, row echelon form, short REF. Apply row transformation to get ones along the diagonal. A leading coefficient is 1 and 0 is below. So you get 1 here and everything underneath must be 0. The diagonal, this one 1, everything underneath is 0. 1, everything underneath is 0, not above, okay? The augmented, well, we do that to the augmented matrix, and I'll discuss the augmented matrix in a moment. What is REF? Then not only, so this one, all of them is 0. This one below is 0, also above. That's the idea. So apply row transformation to get ones along the diagonals and 0 both below and above the augmented matrix. Every leading one is to the right of the one above it, and any non-zero rows are always above rows with all zeros. So if you have zeros, all of them are zeros, should be at the bottom. All right. So we are looking at the same question that we just did, but we want to look at it from the point of view of matrices. First, the augmented matrix. The way the augmented matrix work, basically you write the same thing here without the variables. Write the same thing without the variables. So what is this? Minus 1, 2, minus 1, 5, minus 10, 6. Same thing without the variables. This is called, if you write this matrix, is called the coefficient matrix. This one is called the last column that represents the constant matrix. Each column on the left, okay, represents a different variable. So these are the x's, c minus 1 and 5. This is the y's, okay. That, in essence, represents the equal sign. So every piece of this augmented matrix is known now. Now, remember what we want to do. We want to make this 1, so we can multiply it by negative. And again, there may be different ways of doing that. And by the way, you want to avoid fractions. Normally, it makes it very difficult to work with. So if I multiply this by negative 1, it means I'm multiplying the first equation by negative 1, and nothing happens. We keep the same type of equation. So this becomes 1, this becomes negative 2, this becomes positive 1, and the bottom one is not changing. And remember how the row echelon form works. Underneath, you have to make it 0. So I got to change this to 0. How do I make this to 0? Change to 0. So if I multiply this one by 5 and subtract it from this, or minus 5r1 plus r2 becomes a new one. In other words, remember, I can multiply an equation by any number and add it to the other equation. That's why the row transformation, we use the same methodology. So minus 5r1 plus r2. That means if I multiply this by 5 negative and add it to r2. So this one, 5 times 1 is 5 subtracted from this one. That's the meaning of minus 5r1, or r2 minus 5r1. Anyways, this becomes 0. And then if you multiply this by negative 5, you get positive 10 and negative 10. That becomes 0. And if you multiply this one by negative 5, you get minus 5, and 6, you get 1. So what happens is that, pay attention to the bottom. The bottom, every entry is 0 except the last. The corresponding equation for the last row, 0 equals 1, is a false statement, a row of all zeros except the last entry. Therefore, the system is inconsistent, and the solution to the system is an empty set. In other words, if I were to write this class, please understand, this means 1x, and I'm going to write the 1 minus 2y equals 1. And this means 0x plus 0y equals 1. I want to go back to the equality format. And of course, this means 0 equals 1, which results in our solution. So I just wanted to see I wanted you to see the meaning of that. And so if you, let me erase my work. If you wanted to show this, how would you show it? If you want to use, for a matrices, 2 by 2, you should be able to do it by hand. If it gets a little bit more involved, even 3 by 3, you can do it by hand, but you may use a graphing calculator when it gets involved. So how to enter matrix? Matrix editor found by pressing second and x to the power -1. Use the arrow key to the right to edit the dimension. Put all the entries using the arrow key, press enter. So when you do that, okay, and how to solve a system, you can go to matrix editor, found by pressing second, x to the power -1, math, then REF or RREF, and you solve this. For example, this one, if we put it in, we put the augmented matrix. And if we do REFA, we get this one. By the way, this may be different depending upon the methodology that is used, but this is the same, which indicates exactly what we have here. So just as an example, if we look at the technology here, just to make sure we know what to do, if you press the second and x to the power -1, it gives you the matrix. And you can click on the first one, for example, it brings it up, the one that I've already put in. However, second, x to the power -1. If I go to edit, everybody, if I go to edit, the very first thing I should do, I should put the size. Okay, so for us, this matrix that we have here is 2 by 3. And the first entry, okay, let me go back. So we are looking at -1 as the first entry. Then the second one is 2, enter, -1, enter, 5, enter, -10, enter, and number 6, enter. Okay. So second mode. Okay. If I click on second X, and if I click enter, it brings the matrix that we just put in. See? I didn't put the enter. I did. Okay, let me just go back and see what I didn't put. Okay, this is A, or did I? That's okay. It is. Okay. That's exactly what we put in. Okay, so -1, 2, -1, and so forth. So it brings up the matrix we want. If you do second X and go to math, then you can go down to, for example, REF or RREF and work on this. Okay, everybody? All right, so that's how this matrix thing works. As far as technology is concerned, I just wanted you to see that so you're exposed to it. Now I want to solve this system. I'm going to do this 2 ways. I'm going to do it by hand and also with technology. So the very first thing is to write the augmented matrix. And the augmented matrix 2, -7, 3, -5, 3, 7. And again, remember this line segment acts like a equality. Okay, so if we want to put this in echelon form, first we want to make this one 1. Now, I can multiply this row by 1/2. That means dividing this by 2. And that works perfect. The problem is it introduces fraction that makes it difficult to work with. So let's see if we can avoid that. If we multiply this one by 3 and add this one to it, becomes 1. See, 3R1 plus R2 would be the new R1. Then I get 1, and the rest works the same way. So 3 times this and -5 is 1. Now 3 times this, 3 times this. I want to just just for the sake of argument to show you this one, 3 times -7, okay, plus 3, that means -21, plus 3 is -18, so now this would be -18, okay. This one, I'm going to multiply it by 3, and I'm going to add it to 7. I get 16. So this one changes to 16, this one changes to -8. That's how you work on this. When I erase my work, so you got the 1 here, and that's good. Everything underneath must go to 0. So how do we make this one 0? So we want this, we want to change this to 0. To do so, we can multiply this one by 5 and add it to this one. So we write 5R1. So we keep the first one intact. 5R1 plus R2 becomes the new R2. So if I multiply this one by 5, I get 5 and -5, 0. If I multiply this one by 5, -90 and 3, I get -87. If I multiply this one by 5, 80 and 7 is 87. The next one is to change this to 1. How do you change this to 1? Divide by -87, this entire row. When you're dividing the row, you're dividing the equation that you've come up with. So minus 1/87, R2 is the new R2. So the first one doesn't change, the second one becomes 0 divided by that is the same thing. This one is 1, this one is negative. Now, so you understand what this means. This means x minus 18y is 16. This means 0x plus 1y is -1. And right away, when you have 1 here, it means this is the answer for y. Then you do, it's called back substitution, and you find x. Okay. Now, if I use a calculator, again, this was done by hand, you're supposed to understand and know. If I put REF, notice this is indicating the answer is -1. Of course, the numbers here are different than ours because it's a different methodology that has been used. By different methodology, I mean this part, they did it differently. Okay. However, if we, instead of REF, we do RREF into A, notice what happens. This is the solution. And again, if y equals -1, you can put it here. You see that it gives you -2. If you go RREF, it actually gives you the solution. Okay. Use Kramer's rule to solve the system. Now, what is Kramer's rule? First, let's discuss determinant. The determinant of a 2 by 2 matrix, if A is A, B, C, D, you use like line segments looking like an absolute value. It's their cross product, AD minus BC. That's by definition. So according to Kramer's rule, when we have two equations, two unknowns, the x and the y, they use the denominator, which is the determinant of the coefficient matrix A, B, C, D. And for the x, they change the x coefficients a and c into st. For the y, they change the y to s and t. So one more time. What is the denominator? Coefficient matrix, A, B, C, D. The same thing here. So D sub x over A, that is called the D, the determinant. D stands for the determinant of the coefficient matrix. Now D sub x, the x column, which was AC, is changed with the solution column, the constant. In the case of y, D sub y, you would change the y column. So if the D, the denominator, is not 0, note that we replace the first column D by the solution matrix D sub x, and we replace the second column of D by the solution matrix for D sub y. So notice that one. So that's how we arrive at the answer. What else is there? If D is 0, if the denominator is 0, and at least one of the determinant D sub x, D sub x, or D sub y, or D sub z, because the reason I have D sub z if it's a 3 by 3. If one of them is different from 0, one of them is not 0, then the system is inconsistent, and the solution set is phi or an empty set. If D is 0, and all of those determinants, D sub x, D sub y, D sub z, all of them are equal to 0, then the system is consistent and dependent so that there are infinitely many solutions. So a quick recap. If the denominator is not 0, you change the first column for x to the constant, the second column for the y for the constant. It's the second column, which is for the y, you change it to a constant yourself. If D happen to be 0, depends whether the numerator is 0 or not. If the numerator, both of them are 0, it's a dependent system. If one of them is not, it's inconsistent, no solution. So this one, I hope you see that D is 2 minus 7 minus 5, 3. And according to the determinant format, their cross product, 2 times 3 minus negative 7 times negative 5. This is 6, 35. So 6 minus 35. Negative 29. Now, this one, everybody, I get rid of the first column and I use the constant 3 and 7. That becomes D sub x. So 3 times 3 minus 7 times negative 7. 9 and 49, 58. Now I go back to the D, I keep the first column and I change the second one to 3 and 7. And the cross product would be 2 times 7 minus 3 times negative 5. So this is 14. This is minus 15. And we get positive 20. So D sub x divided by t, that is negative 2, that's x. D sub y divided by t, that is negative 1. So this negative 2, this is -1, exactly the same answer we got before using the Kramer's rule. That's a 2 by 2 matrix. What happens when it's a 3 by 3 matrix? Evaluate this determinant. How do you do that? And again, A11, A12, A13, remember? First you write the row, and then, for example, this one, A21, A22, A23, and so on. And you can expand the determinant with respect to any column or row, and you want to use the one with the most number of zeros, by the way. So the way it works, normally if we go with the first one, so you cross the first one, everybody. And then this one, if you want to use this one, you have to cross this one as well. And what is left is this. So A11 times that. Do you see that? Now the sign alternates. I'll discuss that in a moment also with a different formula. Now, again, we are crossing this one and this one now. So we get A12 times, look at this one. A21 is this, and this is this one. This is what you get. And finally, if you're crossing this one and you multiply, you have this one, and this is the determinant, because we can handle determinant of a 2 by 2. So for this example, so the 2 by 2 determinants are called minors of a 3 by 3 determinant, those determinants, okay? We choose to expand across one row. For example, row 1. Any row or column can be expanded. It doesn't matter. So we are going to put this in red. And what happens is you want to use this times, now cross this, what is left? 5 times the determinant of this one. Now for the second one, we are going to alternate the sign. This was positive, now we're going to go with negative. Positive, now the next one is negative. So you use -8, you cross it out, so you have the determinant of 3 minus 5, 4, 1. Look. Okay. And this is the alternate sign. Finally, we go with number 6. So we cross this out. 6 times what is left? Plus. That's it. So this one 5 times this is 0 minus -8. This is plus 8. 3 minus -20. This is plus 6. Minus 6 times minus 0. So this is positive 8 this is minus 1, the positive 8 times, this is positive 23, plus 6 times negative 6, and becomes 40 plus 184 minus 36, and you get 188. So it's pretty straightforward, everybody, okay? Here's the second method I want to discuss. So we want to evaluate the determinant. So method 2, you put two of them next to each other. So this is one of them. So understand this is being repeated. And you start from the top left and you multiply them, add them up. And then afterwards, after you're done with the 3, then you go this way diagonally, the opposite way, multiply, add them up. Now the blue ones minus the red ones are the answer. So this is how we write it, but you don't have to memorize this at all. Let's look at what we do. We put those next to each other. So we're starting with 5 and we go down diagonally. So that's 5 times 0 times 1 plus negative 8 times 4 times negative 5 plus 6 times 3 times negative 2. Now we go diagonally this way, minus brackets. Now we're going to multiply these three numbers, 5 times 4 times negative 2, minus 8 times 3 times 1, 6 times 0 times negative 5. So you add those up. So you add those up, subtract from it. So the first one adds up to 124. This one minus negative 64, add them up, we get 188. So this is the second method. So if you're doing it by hand, perhaps this is the fastest. Yeah, definitely it's the fastest. Now, also notice, it is easier to expand across any row with most number of zeros. If you are going to go with the method of the previous page, you would use the second column or second row because it has 1 0. Okay. However, if you go with the technology, you put the matrix in, and then you look for determinant of that, and it gives you the same answer. Okay, everybody. Pretty straightforward, everyone. All right, let's solve this system now. Again, there are various methods that you can solve. Let's first call them equations 1, 2, 3. It makes it easier to work. Notice that these two are opposites. So right away, if you put equation 1 and 2 together, you can get rid of the y. So just add them up. Add these two. This becomes 5x, they go away. This becomes 3z, they become 1. So that's a new equation, and we're going to call it equation number 4. Just give it some number, equation number 4. Now, which equation was not used yet? Equation 3 must be used. Do you use it with the first one or second one? Makes no difference. It's your choice. Doesn't matter, but this must be used. And Because this has an opposite sign, perhaps this is easier. So you just multiply this one by 3 and this one by 4. Again, this must be used. So if I multiply this one by 3, let me erase my work. I get 9x minus 12y plus 6z equals negative 45. If I multiply this one by 4, I get 8x plus 12y plus 20z equals 80. And now these two cancel each other. This is 17x, 26z, 35, and I'm going to call it equation number 5, and I'm going to put them next to each other, and a 3 by 3 has been simplified to a 2 by 2. Okay, everybody, that's the idea. And now I'm going to solve for one of the variables. For example, if I want to get rid of the x, I can multiply this one by 17, this one by 5, one of them negative. If I want to get rid of the z, this one by 26, this one by 3, one of them negative. So let's multiply by 17 and negative 5. So if I multiply 17 by the first equation, 85x, 51z equals 17. Minus 85x minus 130z minus 175 these two cancel each other. These two negative 79z, these two negative 158, divide, and you get z equals 2. Now, if you find one of the variables, then you go to 2 variables, not 3, because we can solve it. You go back to either equation 4 or 5. For example, equation 4, 5x plus 3 times z, which means 3 times 2 is 1. And you divide by 5x becomes negative 1. Now you put it back into one of the original equations. For example, equation 1, 3 times x, that means 3 times negative 1, minus 4y, plus 2 times 2, negative 3 and 4 is 1. Move it to the other side, minus 1, and divide by negative 4 is positive 4. And the triplet is negative 1, 4, 2. Please understand, we used equation 1 to get this. You must check. You must check with these two. That's the beauty of math. You can't check, so you must check. Okay? It's very easy. It's just a matter of seconds before you can come up with the answer. Let's look at the same question. We already have the answer. Let's write the augmented matrix. Again, we want to use matrices. So 3, negative 4, 2, negative 15. 2, 4, 1, 16. 2, 3, 5, 20. Just, in other words, write exactly the same thing without the variables. That's all. It's very simple. Augmented matrix, write exactly the same thing without the variables. And instead of equality, use a line segment. Put that into a calculator. We're going to put that, let's say, in my matrix B. We're going to call it 3 by 4, right? 3, 1, 2, 3 rows, 1, 2, 3, 4, 4 columns. And we put in, and I'm showing you the second half of it because there was not enough room. You can do REF. Again, there's not enough room. I will show you the second half. And if I change it to fraction, I can see the entire thing. Please understand, this means the last variable, namely z is equal to 2. Then you do the back substitution. This means y minus 1 over 20 z equals 35 over 3. However, if I do REF, so that's, by the way, that's the um, this is in essence the new augmented matrix, and this is the new set of equations. See, x minus 4 thirds y plus 2 thirds equals minus 5. This one is y minus 1 over 20 z is 39 over 10, and this one z equals 2. So z equals 2 back substitution. If you do REF, this last column is exactly what we got here. So in one shot, it gives you the answer. What about this system? Well, you may notice that if I multiply this one by 8, and combine it with this one. So this one multiplied by 8, you get 16y plus 24z equals negative 112. The third one, you just write it just the way it is. You don't do anything. And these two cancel each other, right? These two, 0. And this add up to negative 224. It's a false statement. That means what? There is no solution. It's an inconsistent system. If you were to put it into a calculator, you write the A matrix. If you REF it, what happens? Or even REF, both of them. Look at the very last row. They're all zeros, except the last entry. So the corresponding equation for the last row, 0 equals 1. That's the meaning of it. It's a false statement. A row of all zeros except the last entry, except the last entry. Therefore, the system is inconsistent, and the solution to the system is an empty set. What about this one? Again, by hand, you may notice that if I multiply this one by 3, so it's the system that, let's say I want to get rid of the x. If I multiply by 3, I get minus 3x, minus 9y, minus 6. And everything cancels out. These two cancel out, these two cancel out, these two cancel out. 0 equals 0, which is a true statement. That means it's a dependent system with infinitely many solutions. And here's the solution. How do you get the solution? You go to one of the equations and you solve for y. For example, this one, you can say negative 3y equals, move the x, minus becomes x. Okay. Plus 2. Now, if you divide by negative 3, you get this. And this is how they represent a dependent system. So one of them is x, one of them is a function of x, okay? Or if there are 3 variables in the same manner. Now, if you put that into a matrix, and again, the augmented matrix, everybody is clear. So you put minus 1, minus 3, minus 2, positive 3, positive 9, positive 6. And if you do REF or RREF, so notice that row 2 is minus 3 times row 1. One easy way, if a row is a multiple of another one, you have a dependent system. So how do you know it's a dependent system? This is 3 times, or in this case, negative 3 times. If you do REF, all of them are zeros. In this case, the corresponding equation for the last row, 0 equals 0, is a true statement, a row of all zeros. Therefore, the system is dependent with infinitely many solutions. So how do you know you have a dependent system with infinitely many solutions? If you get a row of all zeros. All right, want to solve this system. This is the system of nonlinear equations because the degree is 2. And again, you go with the same methodology. In this case, the substitution or elimination method. Clearly, elimination is in order because you just can add up and these two cancel each other. We get 4x squared equals 28. Divide by 4x squared is 7. So x is plus minus square root of 7. You put that into one of the equations, and clearly equation 2 seems to be easier to work with. So we're going to put that into the second equation, everybody. And it doesn't matter positive or negative because it's being squared up becomes positive, and that is 7 subtracted from 16. And y squared becomes 9, and y is plus minus 3. Please understand, this means 4 possibilities, meaning minus square root of 7 with negative 3 and positive 3, positive square root of 7 with negative and positive 3, that gives us 4. And you have to check. And the way you check with the equation you haven't used. We use the second equation to come up with the answer. Therefore, we must use the first one, which hasn't been used. I can't emphasize this enough. We're going to choose one of those pairs. For example, this one. 3 times x squared minus square root of 7 to second power minus y squared minus negative 3 quantity squared. So we check with equation 1. This becomes 7. So 3 times 7. This becomes 9. So minus 9. 21 minus 9 is 12. Yes, it's correct. So that works. And you can work on the other ones as well. So you should check, and it doesn't take long, everybody. It's really a good practice to check. Graph the system of inequalities. To graph systems of inequalities, first we're going to graph one by one by changing the inequality to equality. So this changes to equality, this changes to equality. And you pick up two pairs. Of course, intercepts are the easiest one. If x is 0, find y becomes 0 minus 2. If y is 0, find x becomes 1, 1, 0. This one, the same thing. X is 0, y is 3, 0, 3, y is 0, x is 2. So those are the pairs, and you can graph these two pairs and the line, these two pairs and the line. So I'm assuming nobody has any problem with graphing. Now, we go back and we see less than. So the red one, and by the way, the red one, 0, negative 2, 1, 0 is here. The blue one, 0, 3 is here, 2, 0 is here. So the blue one has the equality and it's fine, but the red one doesn't have equality. It's not fine. It has to be dashed line. That's the first thing you must notice. Then you pick up a test point. The easiest point would be 0, 0, as long as it's not on the line. For any of them you want to check. So it's not on the line, so this is the location. So either, and you put it back into the original inequality, either works or it doesn't. For example, if we go with this one, we get 2 times 0 minus 0 is less than 2. 0 is less than 2 is a true statement. So that works for the red line. This was the red line, remember that? That means if it works, the side containing that point is the solution. For the blue one, if we plug in 0, 0, larger than or equal to 6 is a false statement. So that means for this line, this side doesn't work because this side contains 0, 0, and so the opposite side is the answer. Notice the two lines create 1, 2, 3, 4 regions, and the two that come together is here. That would be the answer, and maybe perhaps it's easier to see it from here. Graph the inequality y is larger than x squared plus 1. Again, quickly change it to equality, and y equals x squared is a parabola that has been shifted up. Now plus 1 shifted up by 1. So this is an easy graph. And of course, this one is 0. So you pick a point. Here's what happens. Inside or outside, pick any point. You can put pick 0, 0, or you can pick a point inside. For example, 0, 2 is inside. If you put it into the original inequality, so you replace the y with 2, x with 0, you get 2 larger than or equal to 1. Yes, that's a true statement. So the inside works. If, for the sake of argument class, if you use, change the color. Let's say you use 0, 0. So 0 is larger than 0 squared plus 1, 0 larger than 1. It's a false statement. And so that's not working. So you are going to make it look like that. Also, going back, this doesn't have a equality. So the parabola itself is not included and it's dashed.